in this problem, we are given a sequence of shapes. So the first question says, how many triangles are there in the pattern with 3 rectangles? So this is easy enough. That's got 1 rectangle, this has got 2, this has got 3 rectangles in it. So how many triangles are there? Well, there's 3 there and 3 there, so that's 6, and 7, 8. So the answer to the first question is there are 8 triangles. Now, question B is a little bit more interesting. How many triangles would there be in a pattern with 5 rectangles? Now, you could draw 5 rectangles out and draw the triangles around them. That's a perfectly acceptable way of solving the problem. But I'm just going to look at it in a slightly different way. So let's just look at this first pattern. The number of rectangles I've got is 1. The number of triangles I've got is 4. In the second pattern, I've got 2 rectangles and I've got 6 triangles. And we just found out that in the third pattern, I had 8 triangles. Now, we should be able to see as this side increases by 1, this side is going up by 2 each time. So our pattern on this side is to add 2 triangles each time we add 1 rectangle. So with 4 rectangles we would have 10 triangles, and with 5 rectangles we would have 12 triangles. So how many triangles would there be in a pattern with 5 rectangles? Our answer there is 12. How about with 10 rectangles? Well, again, we can just continue this pattern, or we can start to look at a different sort of relationship. How can I relate the number of rectangles to the number of triangles? Is there a pattern between these two? So if we just look at this side, we're adding 2 all the time. Now this is very much like the 2 times table, but I'm not starting with 2. I start with 4. So it's like the 2 times table, but I'm adding 2 every time. So if this was the 2 times table, if this was 2, 4, 6, 8, and 10, 1 rectangle would have 2 triangles, 2 rectangles would have 4 triangles. So what I would be doing, for every R, I would be doubling. So if R was 1, I double it to 2. If R was 2, I double it to 4. So the number of triangles is 2 times the number of rectangles plus 2. So what I've done here is I've developed a formula. So for any number of rectangles, I can work out the number of triangles that would be in that pattern. In this example, the question B, part 2, asks for how many triangles would there be in a pattern of 10 rectangles. So the number of triangles will be 2 times the number of rectangles plus 2. So the number of triangles in 10 rectangles would be 22. And that's the answer to this question. The final question, how many rectangles would there be in a pattern with 34 triangles? Now, because I've worked this formula out, I can put 34 in place of T, because I know there are 34 triangles. And I know that is going to equal 2 times whatever the number of rectangles there are, plus 2. So I can now work this backwards. So it's really solving an equation. This is algebra now. So 34 equals 2R plus 2. If I take 2 away from each side, then I know that 2R is going to be equal to 32. Now, I don't know what R is, but if I divide this side by 2, I get R on its own. So I need to do the same to this side, and 32 divided by 2 is 16. So the number of rectangles that have 34 triangles around the outside is 16. So 16 is the answer to question part C.